Hi, my name is Daniel Odamelum, and this is Project 2.9, Unpacked, the 595 shift register. This project recreates the functionality of a 4-bit serial in parallel shift register using discrete components. The circuit uses individual D flip-flops, a 555 timer in monostable mode, and 4 buttons to replicate the function of a shift register IC, like the 74HC595. As a whole, this project takes a look at the fundamental workings of a shift register, giving a clearer understanding of how data is stored, shifted, and latched in digital systems. The 8 D flip-flops, 2 in each chip, are arranged into 2 groups: the main shift register, which comprises the first 2 chips, and the latch output, which are the second 2 chips. A shift register is a digital circuit that takes in data 1 bit at a time, passing it through a chain of flip-flops with each clock pulse. This process converts serial data into parallel output, meaning all bits can be accessed at once. To mimic the separation between input and output, like in the 74HC595, this project uses 2 independent sets of flip-flops. The first group holds the incoming data and shifts it forward with every clock pulse, and the second group only updates when the latch button is pressed. To generate a precise clock signal, the circuit uses a 555 timer in monostable mode. When the clock button is pressed, it sends a low signal to the trigger pin of the timer. This causes the output to go high, creating a rising edge. That edge becomes a clock signal for the first 4 flip-flops, advancing the data by 1 bit through the chain, allowing for the manual shifting of data through the shift register. Each D flip-flop stores a single bit of information. On each rising edge of the clock, the flip-flop takes its value present at its data input and stores it on its output. The value stays locked in place until the next clock pulse. The 4 buttons, data, clock, latch, and clear, make the system fully interactive. The data button sets the bit that enters the shift register, and the clock button advances the bit down the chain. For example, if I'm holding down the data button and then I press clock, it sends a 1 down the chain. The latch button transfers the values from the first 4 flip-flops onto the output latches. So again, let's say I send a 0 this time, and then I latch it. This updates the output. Now you have 0, 1, 1, 0. Finally, the clear button clears the entire system and turns off all the LEDs. These 4 LEDs show the 4-bit representation of the data latched from the shift register. For example, if I entered a 1, 0, 1, 1 into the shift register, it will display as so. Or if I wanted to, I could do it in steps where I do 1, latch it, send a 0, latch that, send another 1, and finally 1, 0, 1, 1. My name is Daniel Odamelum. Thank you for listening.